Hi everyone, welcome back. In the last video, we introduced the concept of struct arrays. Now let's move on to something even more common in real-world applications, the linked list. Okay, let's quickly go over what a linked list is. So here on this slide, we can see a linked list is a data structure that connects each element using pointers. And each node holds some data and a pointer to the next node. Okay, compared to struct arrays, linked lists are more flexible when it comes to expanding or striking the container, because memory is allocated dynamically. Okay, but there's a trade-off. Unlike arrays, you can't directly access a specific node with an index. You have to traverse from the head to get where you want. Alright, time to start coding. First, we need to define a node structure. And since each node points to the next one, we need a pointer inside the struct that points to the same type. Here's how it looks. That's it. Now let's move on to the main function. Let's dynamically allocate the first node, the head of our linked list. How would you write it? Take a moment. Feel free to pause the video and try it on your own. Ready? Here's what we can do. Okay, does this match your code? Just remember to check if memory allocation succeeded. That is always a good habit. Now let's get our head node an initial value. Pretty straightforward. We are storing 100 as the value, and since there's no node after it yet, next is set to null pointer. And next, let's write a function to extend our linked list. We will call it create linked list. Okay, and it will take two arguments. The first one is the pointer to the head, and the second one is an integer size. Tells us how many nodes we want to add. Here's the function. Okay, let's break it down. First, we use a pointer current to traverse from head to the end of the list because we will add new nodes at the tail. Okay, and once we are at the tail, we enter a loop to create size new nodes. Okay, and each new node is assigned a value and linked to the current tail. And then we move current node forward to the new node. Okay, this way we keep appending nodes one by one. Now back in main function, let's call these functions with head node and a size of 5. Okay, And let's check if everything works by printing out the value in the linked list. Just like before, we can use a loop works through the list. Okay? Pretty simple, right? Let's run it and see what happens. Okay, we passed in size equals 5. So we might expect 5 nodes in total. But the output shows 6 values. What happened? Well, it is because we already created the head node before calling createLinkedList function. So that function added 5 more nodes, making the total 6. Okay, so if we want the function to fully handle the creation of the list, including the head node, we will need to tweak the design a bit. Let's save that for the next video. See you there.